Hello, we are now learning Module 6, Day 2, and new setup for the video. I actually learned it for Day 4, but I'm redoing Days 2 and 3 because they were terrible. So today, you do need a calculator. Oops, that was the right side. Sorry about that. You do need a calculator and your notebook. We are continuing with the idea of a circle and sections of the circle. Last time we were together, we learned about the arc length. So let's review a few things on the left-hand side here. This is circle B, which tells us B is the center point. This 4 is the distance of the radius. And if you were to identify radii by like letters, BC and BD are both radii because they start at the center and go to the edge. The diameter is any segment containing two radii side by side to form a segment, a larger segment, I should say. And I'm missing a point, so I'm going to put an E there. So ED would be an example, and the diameter for that circle would be 8 units. The central angle is 80 degrees. That's the angle at the center, and there can be a whole bunch of central angles, by the way, but it's the one involved in our practice problem here. Arc, in this case, because of the 80 being at the center of it, we're going to be looking at arc CD. There's also an arc EC, and that would have a central angle of 100, but we're not going to do that. I would like to know the length of arc CD. The formula, as a reminder, is central angle times 2 times pi times radius divided by 360. We're going to have two different types of answers, one with pi and one without. So here we go. So the central angle is 80 times 2 times pi times radius all over 360. The first answer, leaving in pi, means reducing numbers as best you can. So this 4 goes into 360 90 times, and this is groovy. These zeros cancel out, dividing by 10. So as I look across here, I have an 8 times a 2, so I get 16. On the bottom, I have a 9. And then the pi just sits out here on the side. And 16 over 9 does not reduce, so this would be the length of that arc in terms of pi. If I would like to know the decimal for that, I simply multiply this times 3.14. So with the calculator, oops, let's do on, not a bunch of buttons. So 16 times 3.14, and then I'm dividing that by the 9. And I get 5.6. And I did not have units, so it's just units. If you were asked for a decimal answer right away, you could just put all this in the calculator. 80 times 2 times 3.14 times 4, and then divided by 360. So now today's lesson. What about the area of that piece? In other words, if this was a piece of pie, you just found the edge crust length, but we would like to know how much pie filling there is. Or it'd be a flat surface of pie filling. Otherwise, that would be called volume, but the crust on the bottom, let's put it that way. Okay, so this area is what we call a sector. And like the formula from before, the angle over 360 is giving you the ratio component, and we're just going to insert the area formula for circle here instead of circumference. So the formula will be angle times pi times radius squared divided by 360. So let us compute the area first with pi, and then for B, decimal. So here we go. The area. So it's still a central angle of 80, and then we're going to multiply by pi, and then multiplied by radius squared. Please be careful with that. A lot of people will make this an 8 if they're in a hurry. So just be really aware you're squaring it. Otherwise, if you just times it by 2, you end up doing this formula here, which is not correct. And now, let's see. I am going to divide by tens. There are 2 4s in 8, and there are 9 in 36. And I think that's probably going to be it. So if I go straight across, I've got 2 times 4 times 4. So that's 16 times 2, or 32. On the bottom, we have a 9. And then this pi just sits on the end. So this would be answer to part A. To know what the decimal is, we're simply going to use the calculator. So we go 32 times 3.14 divided by 9. And that is 11.2. And this would be units squared, whereas these were just units. All right, we're going to practice that area formula 2 more times and then do a shaded area like so. Moving right along. 60 times pi times radius squared. The diameter is 30, so this is going to be 15 squared all over 360. Nice. 60 goes into 360 exactly 6 times. 15 squared is 225, so I'm going to write it 225 over 6 and then just put pi on the end. Now let's convert that to a decimal. Now this time, instead of doing this, I'm going to go ahead and do it this. And for those of you uncertain of your reducing, you might want to always use the original in the calculator to get the decimal correct. So I go 60 times 3.14 times, times 15 times 15, enter, divided by 360. And that is 117.8. So there's your 2 answers. With pi, then multiply by 3.14 to get the actual number. Let's do a second problem. If a sector in a circle has a central angle of 20 with radius 4, what's the area of the sector? Okay, we're going straight to the formula. Angle times pi times radius squared all over 360. And the 20 goes into 360. So you can cancel the zeros, and then you're just looking at 2 and 36 if that's helpful. That's going to be 18. I'm going to do 2 steps in here. 4 times 4 is 16, and there's an 18. So then let's reduce those by 2. So 8 over 9 pi. Okay, awesome. Now let's convert that to a decimal using the calculator. 20 times 3.14 times, I'm going to do 16 divided by 360, and I get 2.8. This next problem, you've got a circle, you've got basically it's like a quarter of a pizza, and maybe you're the type of person that only likes the crust. I'm not sure. You never know. And so we want to know the area of the crust as it extends in here. This has a special name. It is called a lune. The books that we use, that of course you don't have with you, they call this a segment. So just for full disclosure, I will always call it a lune because that's really what it is. To find the shaded area of a lune, it's always the same formula. For this class, I will only ask you to know how to do these type with a 90-degree angle in the corner because it makes the problem a little easier. You're always going to find the area of the sector, in other words, the formula we're using here, and then you're going to subtract that triangle. Triangles have the formula length times width divided by 2. And since I'm giving you a right-angled triangle with radii for the sides, it's always going to be the radius times the radius divided by 2. So this should make these problems a little easier. So here we go. So for the sector, 90 times pi times radius squared divided by 60. Cleaning it up. 90 goes into 360 4 times. This is now 100 pi over 4. We're going to actually always do the decimal version of this. So let me just go ahead and do that. I apologize. I started to reduce and I really didn't need to because we're just going to use the decimal. So 100 times 3.14 divided by 4. And I get 78.5. the triangle. Again, I'm only going to give you these type to know. The triangle is 10 times 10 divided by 2 because that's length times width divided by 2. So that is going to be 100 divided by 2, which is 50. And now if I subtract 78.5 minus 50, I get the shaded area as 28.5. And that's all that. And if you physically look at a drawing of this, the sector looks like this. And then you're saying take this away. And sure enough, if you pull the triangle part out, you're left with just that shaded stuff. There you go, folks.